talk about Sputnik and how it was developed, how it appeared, and devices that can be used with Sputnik, and what kind of measurements can you make, what kind of results can you achieve, etc., etc. So we will begin from the beginning. We will start from how we came to an idea of constructing such an antenna. Okay, so to presentation. So we will talk about Sputnik antenna and the device that was constructed or even Bio-Well appeared. It was called GDV Ecotester. So, well, all of you already know what is GDV, an API, and that it is not our. We have devoted special time for that. I have already explained the principle how the gas discharge, the electrophotonic emission, is being formed, and how can we make interpretation of the parameters of this glow when we are talking about fingers. But in case we are of a metal cylinder that we are putting on the glass electrode of the device, well, in the case of Bio-Well, we talk about this one, metal cylinder. So when we put it on the glass, so there are less parameters that we can take into consideration. But anyway, the physical principles are the same. Depending on the properties of the object that is placed on the glass electrode, the electrophotonic emission will have different parameters. So initially they were GDV devices, GDV compact or GDV camera, and the idea was to connect an electrode, external electrode, to the titanium cylinder and see how it reacts on what is going on around. And of course you can put such an electrode to different materials. Of course you can put it to the water, you can put it in the air, you can put it into the soil, or even to the wood, to some tree, into some tree. So this type of measurements. So anyway, as long as we are having very stable metal cylinder on the surface of the glass electrode, we have light around it, and there are main parameters of this light is area and average intensity. And of course the power of light, but this is a dynamic parameter. So it means that we will take into consideration those two parameters in all further on discussions and calculations. So, well, we can go inside in those physical principles, but well, this is an LFC contour, and there are three main parameters there. So depending on the capacitance of the external circuit is the metal cylinder, the wire, and anything that is connected to this wire. So it can be a Sputnik connected to a metal cylinder. So then the external circuit is consists from several parts. Number one is metal cylinder, number two is the wire, number three is Sputnik itself. But there is another one part, invisible one. It is the space between Sputnik and the Earth. So it also has some capacity, electrical capacity. So these all factors change the parameters of this electric contour, and that's why we have the dependence of the parameters of the light around the cylinder from what is going on around, because metal cylinder is stable, it doesn't change its properties in time, well, significantly. Wire also, metal spikes on Sputnik also, they're very stable. So the only one variable is the space around, surrounding Sputnik. So that's what we are studying. So we made experiments showing that area of this globe, well, here it is in pixels, depends on the capacity of the external circuit that I showed you. So you see this dependence, the curve. So it means that when we have, we work somewhere here, it means that increase in capacity for 50 picofarads will give just very slight increase in area. So it will be hard to make such studies. But if we adjust our device that it will work in this range, then even small increase in capacity will give us big difference in area. So that's why we needed to make some adjustments to do such tests. That's why we especially selected the length of this wire, the thickness of this wire, etc., etc., and the voltage of the device that works with it. But it shows that depending on the capacity, we have different signal. The same dependence for average intensity. Also between average intensity and resistance of the external circuit in kilo ohms. So just showing you that we are measuring some exact physical parameters of the surrounding environment, the surrounding space. So in 2000, was an idea to make a mini laboratory kit where a researcher will have different types of electrodes that he can connect to the metal cylinder and then put it into the air, into the soil, into the water, etc., in a material, and study it in time, how it is reacting on some parameters, on some influences, on some sun eclipses or different other things that are going on around. So, and you see the first articles, papers published about this is about, well, application of this mini lab, because it was used also for study not only the space with the electrodes, but also for studies of different materials that can be made instead of metal cylinder. So it was an interesting idea, and then an idea came to create a special attachment that was called GDV fifth element 10 years ago, and it had 5 electrodes So you could connect the metal cylinder from the EPI device to this fifth element, and then connect with different sensors, antennas. So, and then insert in any, well, whatever you grab, really. So that was an idea. So that fifth element was simply rotating its chain connection inside of it, and it was making one capture for each electrode in 5 seconds, and so constantly rotating. So it was quasi-simultaneous parallel measurements. And Dr. Korotkov, I think that he has probably talked about these experiments, but those first studies were published in 2005, that these sensors demonstrated interesting data which may be related to energy environmental conditions. Further experiments would allow to get more precise definitions. So they were only first results that were received at that time by Professor Korotkov. That it is picking up something. So the only you could say that they are interesting and there is something to look at. So it picks up something, but what it is picking up, we don't know. So you see those graphs. At that time, there was no strict methodological recommendations how to process this data, what kind of noise filtration and the data processing should be applied to be able to rely on the data that you receive. But anyway, it appeared that there were some differences, but what it was and what was the difference between these and that, and what does it mean after all, the most interesting question. Nobody knows, and nobody knew at that time. So then his next expedition to Colombia, also with the sensor with antenna, the regular radio antenna, and conclusions that he has made that fixed element sensor is promising for studies of J-active zones on Earth. But what are the correlation parameters besides GDV data that were taken into consideration? None. So like it was almost impossible to make any interpretation of the data that was received. So it was showing some differences, but what it was due to, no, he didn't know. To Korotkov lab in 2007, and first thing that we started doing with Professor Korotkov is developing a standard procedure, how to make these experiments and how to acquire stable and adequate results. So then, of course, there are different natural, the destabilizing factors are influencing the measurements, and they, of course, need to somehow neutralize. Of course, we need somehow to process the data in some specific way each time, so we can rely on the data. And after all these things done, we wanted to develop a standard procedure of how to do such experiments. So after making a lot of experiments with the devices that were available at that time in 2007, we have found that these are the main problems when making experiments with the GDV EPI devices at that time. So one by one. Bad grounding. If this EPI GDV device is not grounded well, it is working less stable than when it is grounded. So the basic recommendation is that it's better to, if you're working in the room where there are a lot of different sources of electromagnetic field, it's better to ground the device. You will have more stable results. If it's not possible, then okay, we'll just the deviation of yours will be a little bit higher. Also, it is recommended to do such things when you're working from the mains. It means all the previous devices were GDV devices were able to work only from the mains, from 212 to 20 volts. While only GDV compact was able to work with the battery, inbuilt battery. Of course, there was possibility to connect the any 12 volts battery instead of mains, because all GDV devices works from 12 volts source. So even if you go by car somewhere, if you have the wires to connect the car accumulator, you can plug it into the GDV device. If you're working from battery, then the influence of grounding is not sufficient, really. But if you're working from mains, then grounding is an important thing. Well, now when you're working through with Bio-Well, Bio-Well is not connected to mains, it's connected through USB to computer. So this is not so important. Next thing is ventilation. This is the same thing here that we have in Bio-Well still, is that when you put metal cylinder here on the device, then the air inside is closed and there is no ventilation inside. So there is no air circulation. And after some time, well, I think that possibly if you have already worked with EPI devices, you already noticed that it smells with ozone after you worked for several minutes with it. And if you close with the metal cylinder and there is no circulation of air, then ozone is being accumulated under the cover, and it makes the results less stable, and reproducibility of the results decrease, and sensitivity. Yeah, of course, fingers also smell ozone, yes, but the measurements with fingers are different, because when you measure fingers, you put it inside and outside, and there is some, you open the cover to clean the glass, etc. So there is some airflow. It is not stagnated there. So it is not the problem with the fingers about bad ventilation. It is the problem of making long measurements for half an hour, for hours, because some of measurements were made for several hours in a row. So then it is a problem. At the present moment, there is no ventilation in Bio-Well. Well, really, in the first model, if you see at the bottom of the device, there is a ventilator, but it is not even functional. It is not working. And it is not solving this problem of ventilating the inner space. It is ventilating the inner part of the device, the electric scheme, but not the undercover space. And that is the main problem, because if you are not ventilating that undercover space, then if you see this graph, these are two experiments made. Number one, when you take different capacitors and make 4 tests in a row, and then repeat the same experiment without any ventilation and nothing between these series, and just change the capacitors. So what I made is just I have connected the wire, the ground, and just cut this wire and put the capacitor in between. So this place stayed closed all the time during the experiment was made. So after all, after repeating 2 times this series, you can see that reproducibility of is very low. You see the difference between equal physical parameters of the external circuit. There's a big difference in first series and second series of measurements. But if we make ventilation after each measurement, so we make a series of measurements, open the cover, blow there like this, and close the cover, make next measurement, open the cover, ventilate, etc. You see that reproducibility became much better. So that's the sense of ventilation in such measurements. Well, at the present moment, we still have this unresolved issue with the Bio-Well, and we're working on it. Possibly in next modifications of the device, there will be ventilation. But at the present moment, you should understand that in the beginning device, it's accumulating ozone. And then when it finds some balance between the concentration of ozone and the fresh air, well, of course, it's not absolutely 100% tight, this cover. So, of course, some air goes inside, and you will anyway have some exchange. But it takes time to reach this balance. So, next thing is warming up of the device. For those devices that we were working in 2007, they could have been warming up for 20 or even for 30 minutes after you start working with them. So first 30 minutes of the data are not well, useless. So you had to wait until the device will start working normally. These modern devices are warming up very fast. We will see we will make some online tests, I think. We can do it right now to see these things. I will just now connect Sputnik. Connect it to the metal cylinder here. Yeah. And now I will share the screen so you will see what is going on my computer. Okay. I will switch off my video for the time that I am showing you the desktop, so the bandwidth of the internet connection will be enough, sufficient. So, until now, everybody understands what I'm talking about, yeah? Yes, okay. So, we go to environmental test and click start. As long as we know that the device should warm up for some time, so in the Bio-Well software we have made it obligatory to warm up the device before starting the measurements. I will adjust now, wait a second. Okay, so we see two main parameters on the screen now, the area and the intensity of the glow. So in the environment mode, we don't see the image itself. We see only the graphs in real time. So we're just watching on how the device works and what time it takes for a device to stabilize. So, but you have seen that first minute was just warming up, and now it is showing the graph in real time. You don't see my desktop. Wait a second. Once again. Can you see now? Yeah? Yeah, okay, good. So, you see the graph, the area and the intensity, two main parameters. Of course, there is possibility to see the energy, but the energy is simply multiplication of area times intensity and times correction coefficient, but it's the same thing. So just by observing how the device behaves itself in time whilst you are just sitting and doing something right next to it. Well, you see this spike, it's because I touched the Sputnik and moved it to another place on the table. So you see that your real experiment starts from these line. All the rest before all those 3 minutes are not taken into consideration. They are treated like warming up. So, but just look at the intensity, for example, graph. You see how it deviates now, and what was the deviation before. So it was several times higher. That's the sense of warming up. That's the sense of preparing device to measurements. So at that time it was much more important to do that, because those devices were much less stable than the modern devices like Bio-Well and the EcoTester that has even inbuilt ventilation. Okay, so that's how these measurements are being made. So you can see these things, these 2 parameters, and according to the experiments that I was making for all these years, well, I found that the most interesting parameter is deviation of area, this one. So to make interpretation of the results, I'm paying much more attention to this parameter than to all of the previous initial 2 ones, the area and intensity themselves. Okay? Well, let's continue the experiment. So let's go. So this experiment will go on whilst we are continuing with the webinar. Just let's return to the presentation. So, at that time, the warming up really made a big problem for measurements. So you had to wait for a long time before you can really rely on the data. Also, at that time, there was no such possibility to fix the metal cylinder to ideally fit flatly lie down on the electrode. So that's why these constructions were made in 2009, 2010 to press the electrode, the metal cylinder to the electrode. That is used now in all the devices from now on, from that time. So let's see examples. So for example, if we simply make measurements, then open the cover, take the cylinder off, and just the glass electrode with the tissue. This will be the difference between these 2 measurements. So this is the average value of the first, and this was of the second. And look at the deviation of the second measurement. It's almost twice higher than the first one, simply because we just cleaned the electrode with the tissue. So that's why the position of the device should be stable during the experiment, and you shouldn't move it to any place. So if we are doing an experiment, you shouldn't touch neither Sputnik, neither device, so not to disturb it. So there was an excessive illumination on the sides, and we had to apply special radius working radius that cuts everything that is around it and calculates only those that are inside. Of course, the processing of the data in the program was also very significant. So the conclusions after finishing all these experiments and all these things were that we need to make some ventilation, we need to ground the setup or use the later, we should warm up the device, do not touch the electrode, use proper settings in GDV Scilab, the program at that time that was used for processing of the data. And the time interval between the captures should be at least 5 seconds. That is already inbuilt in the Bio-Well, because for previous devices it was possible to make captures even once in 3 seconds, but it was much less stable. So in 2009 there was a methodological guide published and in Russian and in English, and where all these things are described, and also is explained how to make the statistical analysis of the data. So how to compare two measurements, how to compare two types of measurements, like before and after, or two groups of numbers, values, the most simple ones. So this methodological guide, well, I'm not sure if you can find it on the website, but if you're interested in this thing, then you just write me an email, a letter, and I will send you this methodology guide. Okay? Well, in PDF format. So I came to Dr. Korkov with an intention to make water experiments, to study how water reacts on different types of influences. And at that time, the setup that was standardly used is the syringe with a small water drop at the bottom that was held right above the electrode, and we got gas discharge, the electrophotonic emission from the water drop. But the problem with that technology was that not in the syringe, not in the device, not in the programs even, the main problem with those experiments was the operator, a person that was doing these experiments. The operator was giving several times higher deviation and higher error than all the rest of the errors of the equipment, programs, etc. So just in comparison, the accuracy with which I was able to make this water drop was like 15 or 20% deviation, but all the rest was like fitting 5%. So what does it mean? It means that when you're doing these experiments, you have to put the water drop each time equal. But that was the main problem, to put it each time equally, because the only measurement device that I have was my eyes to see if the water drop is the same or not. So anyway, I was very eager to study the water and the influences, different type of subtle influences on it. And I have conducted an experiment, the influence of the pyramid on the water. I've constructed a model of the pyramids. It was like 50 centimeters high, and the glass pyramid covered with the paper, with the metal film in the inner layer, etc. and I put one bottle with water, tap water, under the pyramid. The bottle was tightly covered with, and another one right beside the pyramid, and left it for some time. The bottle outside the pyramid was covered with a black tissue just to avoid the sunlight. Well, any light really, because water doesn't love sun. So, and while doing those experiments, I found that it's not even possible to see the differences between these two waters, even after it stood there for 1 day, for 2 days, no difference. 3 days, no statistically significant difference. 7 days, 1 week passed, no statistically significant difference. Only after this water stood for 1 month under this pyramid, and I made the measurements, I was able to have this statistically significant difference between the waters tests. So the area of the water that stood under the pyramid is lower than the area of the water that stood near the pyramid. Well, there were some conclusions made, like due to structurization of water, the area of glow is lower because the hydrogen bonds and other bonds between the molecules became stronger, and that's why it is, while applying the same voltage to these water drops, it's easy to destroy these bonds from the non-structurized water that was near the pyramid in comparison to the water that was more structurized that stood under the pyramid. So it was like preliminary conclusions. But the main thing with this experiment that it took 1 month to be able to register the difference, because after 1 week I was unable to do that. And of course we were thinking how to develop this thing, and we started using platinum electrode, the water sensor, water electrode. Well, now we are also thinking of selling these things for Bio-Well. So for those who are interested in doing these experiments with water, with some long-term influences, long-term events, etc., that you want to study. So we decided not to put the water drop to the above the electrode. We decided to put the metal cylinder and connect to the water electrode and put it into the bottle. Well, it appeared that this method is much more reproducible, because operator is not influencing on the results, but minus was that it is less sensitive. So that's c'est la vie, that's life. We couldn't do anything, but this method, much more reproducible but less sensitive. That method is much more sensitive, but which electrode that comes with the calibration pack. Well, the thing with the standard electrodes is that if they are made from regular metal, this metal become rusted in the water. Platinum electrode, because it is not rusting in the water, and it stays at the same level, at the same properties as it was in the beginning, and then that's why the results are much more reproducible. Because if you put even the Sputnik, it's possible to put even Sputnik into the glass of water, but you will see that Sputnik in some connection points will become rusted. Okay. Let's go. So these conclusions. So at that time I was reading a book by Krzyzewski. Yeah, it will rust after some time, the Sputnik, but it's possible. That's how I made those experiments in the beginning. Well, really, I can even show you one of the first prototypes of Sputnik if you want. This was antenna that, according to the Krzyzewski principles, the ionization of air happens if you apply high voltage to the very acute needles, metal needles. On the edges of these needles, the ionization starts. So I thought that maybe it will be much more sensitive device for studying water. If we won't put the platinum electrode with one needle, but the hedgehog with different, with many acute needles, and who knows, it can be much more sensitive. And at that time I made the first Sputnik. It wasn't called Sputnik at that time, and I just taken those needles from my wife. I borrowed them and just wired them with the metal wire and connected to the metal cylinder, and it appeared that it's more sensitive and it works well, but it wasn't good to work with such sensor in the water. So it was because it started rusting. So maybe you've heard about Krzyzewski and about light ions in the air that are very, very important for human beings when we're breathing the air. So that's why many people are using air ionizers in their homes and offices. Have you heard about these things? Well, just type in the Google air ionization. So there are special devices like Krzyzewski lamps that are hanging on the ceiling of the room and ionizes the air in the room. And there are special resorts where there are special rooms with very high concentration of ions that are artificially made by such devices. So Krzyzewski was one of the first scientists that proved the auspicity of the positive and negative ions. Yes, and the main thing is that light ions, air ions, should be present in the air constantly. And for example, if you go outside in the street or to the forest, especially after the rain, the level of ionization there, of air ionization, is much higher than in the closed rooms and closed construction buildings. So it is an important thing to ionize the air inside Yes, of course, you can even smell it. And it's very important to have air ionization in your room or in the office. And but there is one trick there, that's it's bad to ionize not clean air. So it means that first the air should be cleaned, and after that it should be ionized. But there are special devices like air purifying systems that are cleaning the air, humidifying, and then ionizing it. So that was the ideas that we developed at that time, and the first time Americans have seen this sensor, they said, "Ah, that's Sputnik from USSR." So from that time, it became name of this sensor, GDV Sputnik. So, of course, the main problem was corrosion. And we have thought that we have relative humidity in the air anyway, so let's put Sputnik in the air and we will measure the water in the air with the same sensor. And I made experiments comparing the standard antenna that was used by Dr. Kharkov in his expeditions with the new Sputnik, and by applying the same influence, I've registered that Sputnik is much more sensitive. So it picks up the influence, whilst the regular radio antenna, the electrode from the fifth element, it doesn't even really statistically significantly changes the signal. This average intensity, previous graph was area in pixels, this graph is average intensity. So, and a special device was constructed, that's a standalone device that was called GDV EcoTester, that was made specially only for environmental studies, nothing for nothing else, just for environmental studies, because it doesn't work with the computer. It writes down all the data to the USB flash drive, and after that you take these images and process them in a special software and build those graphs afterwards. In this device, there was a special pressing spring that pressed the metal cylinder to the surface of the electrode. So even that you were moving the device, the position of the metal cylinder didn't change. It worked from the external battery. And by the way, this is one of the second or third generation of GDV Sputnik. I can even show you one of the first initial ones for a second. If you can see this, they're just bent needles. They're much more flexible than those that we're using now, and if it's possible for you to see, it's all around rusted with the corrosion, because I've used it under the water. Just test it with the water measurements. So the GDV EcoTester device is a standalone. It writes everything to the flash drive. Due to it doesn't connect to a computer, so it has lower deviation and high sensitivity. It also has the inbuilt non-stop ventilation, so there is constant exchange of the air under the cover. So not like in the present version of Bio-Well or all other EPI GDV devices, this is the only device that has this ventilation. So it has higher stability and higher sensitivity also, because it reacts on the changes in the environment. And it works from accumulator for hours, and like it can be even for days non-stop working. So we can apply this to study environment, to study human emotions if there are people around it. We can use it for detecting of the GI active zones. We can use it for monitoring of plant state. If you put the electrode into the pot with the flower. You can also use it for studies of water and other liquids. Any studies with the use of electrodes. Okay, so this is the finish of this presentation, and it's already 1 hour past. I would like to take a break for 5, maximum 10 minutes, and let's return in average. Okay, 7 minutes, we should be back. Okay. Yeah, I will explain how to study human emotions, etc. Okay? Okay, making a break. Okay, everybody's back. Last one. Shazam. Okay. Okay, one question. Welcome. Well, it is an idea, of course. We thought about this. It's possible. If you will look at the modern version of the Sputnik, it is covered. We're thinking about updating it and making it more durable to the environmental conditions, to humidity, to water, etc. But, well, it will take time. I think that after some time we will make them next generation. At the present moment, it is as it is. Well, you will be one of rare people in the world who have seen the first Sputnik. Would you like to see? Yeah. Yeah, I will just put something black in. So this is the first Sputnik. It's a little bit not in the correct order, so I was doing it like this each time when I needed to make tests. So they were changing the directions. So this is the first one. Funny thing. No, it's not after crashing. It's normal normal state of this Sputnik. So because I just used standard wire and just molded several small wires to it and connected with the needles and then molded all. And that's it. It was on the pencil. So the first tests were done like simply putting the pencil and some with the tape to this to the table. Yeah, that's the first. Well, I'm keeping it my personal museum. This is the first one. I even made some tests with it. Not even here. We were invited with Professor Kortkov to a reconnective healing workshop in Amsterdam, and I was using exactly this one, Sputnik there, and everybody was coming and watching it. It was saying, what's the mess is this? But yeah. But anyway, that's just a part of history. Okay, so let's move on to the next presentation. Do you have any questions regarding the first part? No? Everything is so simple? Okay, so let's talk about spheres of application. Okay. So you have already seen this setup. Now we are for using Bio-Well in some cases. Sometimes we are using GDV EcoTester. It's much more expensive. GDV EcoTester is worth 4,000 euros. That's the main problem with the spreading this technology, is the price. So I've explained you the setup already. You know it. You have. Let's move over to what we are measuring with it, because when you see the results, there can be very many questions. How did these parameters change? Due to what? And of course, there are many factors that can alter the area and intensity of the globe. Chemical composition of the air. As long as it is a gas discharge, electrophotonic emission, it's air discharge, it means it depends on the chemical composition of the air. And number two is relative humidity of the air, because these parameters, the relative humidity also changes the physical properties of the air and the gas discharge and the electrical capacitance of the surrounding space. Temperature of the air can also be changing during the experiment. Air pressure, magnetic fields, electromagnetic fields, geo or technoactive zones, well, also concentration of aeroions in the air, and if there are some living things walking around the Sputnik, they can also change their properties. So let's try to understand what we are measuring when we're doing experiments. So first, that I've explained you already, that we are looking at area, average intensity, and first of all is the standard deviation of area, most important parameter. So while doing experiments, I've discovered that even in a closed room, even that there is nobody inside, nothing is happening there, no electrical devices working in that room, signal can be different in empty room. And so after a while we have found out that there is some signal that can be treated as normal. And normal according relatively to what? That was the main question that we will answer in the end of this presentation. So then, influence of the relative humidity. You see, well, the changes in time of the humidity. So it started from 68 and changed over to 35. This is the number, consecutive number of the EPI image, and this is intensity graph, this is area graph. So you see that the change delta here is very low. So it was closer to 8,100 in the beginning, and moved over to 7,700. So if we calculate in percentage, well, it's only 400 pixels, so it's like 5% difference. Another thing that is like 400 pixels difference, whilst the relative humidity changed from 68 to 35, so it's more than 30% deviation. So 30%, well, if you take a device that is measuring relative humidity in the air, you will see that if you are not doing some specific things in a room, relative humidity doesn't change for such big numbers. You have to really put some air humidifier to change drastically this parameter. In normal conditions, it will be like 1 to like 3%, not more. So it means that when we see big alterations in the air and intensity in our graphs, it's not relative humidity, of course. Air temperature. So see again graph from almost 17 degrees Celsius until 10 degrees Celsius. And here's the change in the air and in intensity of the globe at the same time. So also you can understand that air in the room doesn't change so fast. Really, to move the temperature to 1 degree in normal conditions, if you're not simply opening the window and letting the snow and the winter air come into the room, there will be no such big changes. But of course, in all our experiments, we were trying to make them in the under control conditions. So we were air humidity, air temperature, air pressure, activity, and even a level of ionization of the air during that time. So when we're seeing those alterations in the signal, that's also not air temperature, because air temperature is not changing so fast. Some people were saying that when we're having those oscillations in our graphs, that's due to the acoustics. That's simply, well, if I'm speaking, then it's one thing, then if I'm not speaking, that's another signal. So it's very easy to check, because you can record the sound and then reproduce the same sound, but without a person being present in this room. So that's what I've done. I just put the device with the Sputnik in the room and turned on the radio, well, very loudly. It was really very loud sound, and it stood there, you can see, from 1635 until 1655. So it's like for 20 minutes the music was playing very loud, and as long as it was radio station, there were different types of music, so different types of voices, different types of frequencies, etc., etc. But you can see that there is no reaction at all. So device is not reacting on the sound, on the acoustics. It is picking up something else. So then there were experiments with the atmospheric phenomena. One of them is the sun eclipse in Siberia in 2008, and they were old devices used at that time, and with the regular antennas, not the Sputnik ones. But even those devices were able to register that the signal before the sun eclipse, the parameters are different, and you see that those oscillations before and almost no oscillations of the parameters after. And also we tried to register if this setup is able to register sunset. And it appeared that if there are no clouds on the sky and the sunset is visible, then device picks up and registers this event. So you see here on the graph the time when sun goes down, and then everything stabilizes afterwards. Well, you see that I was making a long-term measurement, so it was like 30 minutes before the sunset. The actual sunset took like almost 20 minutes, and then more than 1 hour afterwards. So it is picking it up. What it is picking up, we don't know really. In the case of sunsets, we have only ideas, no real scientific proofs or conclusions. At the same time, I was registering the luminosity, the light. So just thinking that possibly the device is simply picking up the luminosity. But it appeared that, yes, luminosity of course decreases when the sunset goes on, but it doesn't correlate with the results that we receive. So that's not luminosity then. Another thing, that we were registering emotional state of people. It means that if you're putting the same antenna in a room where there are people inside, it's not an empty room, then of course we are, as a human beings, we're also emitting something into the air. So we are changing chemical composition of the air during that we are present there. And number two is that as being a conductive object, while having some emotions, we change our physical parameters, inner physical parameters, and due to that we change the from an electrical point of view, we change the properties of the environment around the Sputnik. So one of the first experiments that we were making with Sputnik was during the musical performances in Philharmonic Hall, in a concert hall, and this one case is there was a choir singing, and the device with the Sputnik was standing behind the stage. There were no people like within 5 or even 10 meters distance from the device, and it was registering one image in 5 seconds during all the concert. So you see those green lines are the songs, white are the intervals between the songs. So of course we were sitting in the hall and we were making logs. So we were writing down what is going on at what time, so then to make this correlation. So here the same songs, and this blue time here is the time when everybody left the hall, the concert hall, and went away. So we will treat it as a baseline. So then we can compare all the rest to this one. So it appeared that standard deviation of area parameter during different songs was different. So the highest deviation was in the beginning of the first part of the concert, and then it lowered down a little shift one song, and then it decreased almost to the same level as it was. Well, there is nobody else in the room. So then there was a break, coffee break, and also in the second half, the direction, the deviation of the signal was higher. How we made interpretation of this is that the higher is the deviation, the higher is the emotional reaction of the audience to what is going on the stage. So it means that if people are bored and really they're exhausted or they're tired or they don't care what is being sang on the stage, then the deviation of the signal is same as for background readings when there's nobody in the hall. But if people are really happy and expressing some emotions while listening to the music, to the songs, the deviation increases. So we can say that the first two songs had the highest impact, very much, and in the second half, these three songs were most impressive. So that's our conclusions that we made, and that's how we made interpretation of this data. Then Professor Kharkov made measurements remote to ceremony on the Baikal Lake, and you can see that there are special time spots, 1, 2, 3, 4, 5, 6, at Whitwell, like first meditation, then some presentation, then collective meditation, then song, etc. So for example, here is everybody singing a song. You see? This is the time when everybody is singing a song. You see that the level of deviation here is much higher than if we take into, well, the time when everybody was meditating. So it was much smoother line than here. So that's our interpretation of these graphs, is that in the beginning of ceremony, everybody was very excited about what is going to be here. And then with that meditation, it's stabilized. Then Masaru Emoto presentation stabilized. Then collective meditation here. And blessing of water. And then a song that gave high, well, very high deviation, and then end of the event, and then it goes here to the baseline. So it is picking up something that is happening with the people. So we made a lot of such experiments in the theaters, in the concert hall, during the rock concerts, etc. During drama, theater performances. And in each case, we were seeing that how the audience was perceiving, reacting on what was going on the stage. The signal correlated with that. So we made special experiment also with weak influences. Information psychological. So we used two approaches. We were monitoring the surrounding space with the Sputnik, and we were monitoring the state of people who were in the room before and after. So before they entered the room and after they exit the room. And there are different types of distant non-contact influences on operators. And we decided to use the acoustic. And notice the physical explanation that if there is a conductive object, like a human being, change the distribution of the electromagnetic field near Sputnik. That's why the signal will change. So then, of course, some of people said that we're picking up the movement activity of people. So that's not about or something like that, or the constant level of concentration. That's simply about if they're moving more or less. And we made an experiment with two people. There were only three, me and two more people in the room. We were sitting there and talking to each other, and you can see that deviation of the signal changed depending on what was going on. So you see that, for example, in this moment, there were vivid discussions. We were discussing with each other what it is, la la la. After a while, this period of time, I was explaining what it is, etc., etc. And then there was time for meditation, and you can see that it was going up and down, then again down, again up, again down. And after these people finished, they were doing meditation, 2 of them. They said that they really had 3 stages of meditation. So 3 types of meditation. The thing is that I couldn't understand that by simply watching them. They were simply sitting and nothing doing. But according to the data of the device, I could make a prediction that there were like 3 periods of times when they were entering deeper meditative state. So, well, it means that the results, it's not even movement activity of the person. So we were trying to test all these things. Also, we were using 20 Hz sound on people that were in the room and working computers. And we were measuring their state before and after they were entering the room and after they left the room. And also we were measuring the Sputnik, the area. So this was the area in pixels and standard deviation in pixels before the influence. This one during. First 10 minutes, last 10 minutes of influence, and then when we switched off the 20 Hz sound. So we can see that the deviation was 95. When we just started the sound, initiated it, the deviation decreased. So it may, well, it correlates with the explanation that first, people have to adapt to a new stress factor, like infrasound, because 20 Hz is almost infrasound. And that's why the deviation became lower, so because of the stress applied onto the people in the room. After some time, people got adjusted to it and increased their metabolic activity. Well, this is like one of the explanations that we give to be able to work even in such conditions when there is additional stress factor. But when we switched off this influence, in the deviation a little bit and decreased. So from the logic point of view, that correlates with the logic of how people should react on such kind of influence. What is interesting is that when we measured this people, they didn't know that we were switching on this infrasound. They didn't hear it, they didn't know. But we asked them to fill the tests before and after, the psychological tests, to make self-assessment. So they were average values of different questions there that were related with health, activity, activeness, and mood. So it was 5.5 before, 4.5 after, 4.8 almost before, and 3.7 after, 5.4 before and 4.7 after. So just to understand that it was really the influence of low intensity sound, but not simply of sitting and doing something near the computer. We made second tests when there were a group of people and there was no influence, group B. And you can see that their parameters stayed on the same level. So it means that people really, those people really reacted on what was going on, but they were not understanding what is going on. Only our measurements explain what it was, and only we know what it was. So it means that somehow the Sputnik is picking up how people in the room are feeling themselves. Are they under the stress, or they're feeling okay, or they're excited? Well, in 2011 I was presenting this ventilator in the room can affect your mood. Well, well, I don't think that a ventilator can affect my my mood, but who knows? If it's really making infrasound, then of course yes. You won't even understand that it is affecting you, but it will. It is, yeah. It's possible. So, just one of the last things is that when I was presenting this technology in India, and we were sitting in a room, and the tester with the Sputnik were standing in the center of the room, and you see there's marks 1, 2, 3, 4, 5, 6 in time, and I was just asking some person to log, to write down everything that is going on in the room, and then just in front of these people we calculated the results and watched the correlations. Oh yeah, 19 hertz, yeah. So no, we were using 20 hertz in our experiments. That's not infrasound yet. Okay, so you see that, for example, the deviation of the signal, there were vivid discussions and everybody was arguing. So that's, one second, it is the highest level, yeah, here, but then it was a tea break and everybody was sitting and drinking tea, coffee, and you see that the signal is almost a line, yeah, the deviation is very low. Then everybody finished, started talking, discussing, and I started explaining the technology. Then again, everybody's speaking la 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 la, and then after it is India, they started making Om invocation. Several men. So you see this number 4, and then a woman said, "Okay, let's make a comparison. I will sing Om alone without anybody," and you see that again, while a woman was singing Om, that was almost one smooth line. So the variability, the deviation of the signal was lower in this time, this period of time. And then when all together, it's also a different signal. So it's also understandable that everybody, when everybody is calm and silent and sitting and drinking coffee and tea and concentrated only on that, that's very low deviation of signal. So if we look here, yeah, the lowest one when everybody was concentrated on drinking tea and coffee. Then next, when everybody was listening to me and what I was explaining, they were also concentrating and trying to understand what I'm talking about. And then again, vivid discussions, Om invocation, and then you see that again, low level is when a woman was singing. And it's also understandable is that when a person, any human being, is listening to a woman's voice, it's like a mother's voice. So then standard person will calm down by hearing a calm woman's voice. So again, we see, and our measurements prove that. Well, that's the interesting thing about such measurements that can be done with the use of Sputnik. But, well, by doing such measurements, I've understood that if there is nobody in the room, we can have different signal. And I started developing approach, activity level of space or activity level of environment. And, well, briefly just make an overview, because this we will be discussing on the next lecture, next webinar, that there should be some norm for people, for the space to be in, and norm will be relative to the person, to the properties of the person that is inside of this space. And of course, maybe you've experienced yourself that there are places you enter and you're eager to do something, to work, to like act, do some activities. And there are spaces where or some rooms or houses where you enter and the only thing that you want is to sleep or to eat, only to restore the energy. There is no other activities that are coming to your head at places. They are very passive. So, and also hyperactive spaces. Well, if you have experienced that, then you understand what I'm talking about. It means that each space has its own characteristics that will influence on us, and then we will have to adjust ourselves to these spaces. And it is possible to somehow measure it, make an assessment, measure these spaces, and calculate and find out where are norms for such spaces, and norms in comparison to what? Because this level of activity of the environment should be correlated with the state of the person that is living or working in such an environment. That's what I was developing in my research for several years already, and we will devote next lecture to this topic. So I thank you all for your attention for today. If you have any questions, just can ask now. Wow, no questions. That's good. Okay. Giselle, you're welcome. And Laszlo. Okay, no more questions. Excellent. So then, see you all next time. Yes, and next time I will explain you one of the main applications, how we are using Sputnik here, how I'm using in my own company in St. Petersburg to make research to study the interaction of human being and the space. So to understand which spaces are more auspicious for people to live in, which not, and to find out solutions, to give recommendations, and we call it quantum feng shui or scientific feng shui. So like we try to study the interaction of human being with the environment, but only from this scientific point of view. So to understand these things, we make only things that are measurable. So we measure the space, we measure the people, and then we proceed. So that's going to be the next lecture. Okay, thank you all for your time, for your attention. Hope to see you next time. Yes, who's still? Yeah, bye-bye. Bye-bye. Nice day to you.